Electrostatic discharge, or ESD for short, can be an impressive, powerful display of nature. An awesome ESD event is the brilliant flash of lightning lighting up the night sky. On a smaller scale, it can just be a nuisance, such as frizzy hair on a dry, windy day, or getting a small shock when grabbing a door handle. So, what causes electrostatic discharge? Normally, there is an available path for charged particles to move easily and safely to the Earth's ground. If that path is broken or blocked through an insulator, the charged particles build up, waiting for a chance to move to the other object. When the objects get close enough, or enough particles build up to overcome the distance, they will jump and cause a spark. Often, these sparks occur on such a small scale that we can't see it or feel it. But while we may not notice it ourselves, many electronic devices are so sensitive that they can be damaged or ruined just from these tiny sparks. In such an ESD event, when charged particles jump from one object to another, they can break a trace or short a circuit, both of which can cause a part to fail. Even if the part does not fail initially, these discharges may cause partial or latent damage that will shorten the life of the product by causing premature failure through normal use. Using an ESD goalie to intercept charges and to provide a path to safety, delicate electronic devices can be defended against electrostatic damage. If a more powerful charge attacks, this single point of defense may be overcome. To manage these more powerful attacks, a more complete and robust defense needs to be adopted. A well-integrated, comprehensive ESD defense plan will limit damage and minimize failures and product returns. In fact, damage from ESD is one of the most serious problems facing the electronics industry today. In the United States alone, the damage caused by ESD has exceeded hundreds of millions of dollars yearly. It is the cumulative effect of ESD damage that adds up over time. For example, a motherboard manufacturer might ship 1,000 boards per week with a 1% fallout rate, half of which is due to ESD damage. That would be 5 boards failing each week due to ESD. If the boards cost an average of $120, that's a $600 per week loss, or $31,200 per year in product failures due to ESD damage. Products that later failed due to latent ESD damage and are returned are even more costly. The manufacturer must spend additional money on customer support, shipping costs, and factory debug testing. The financial impact and damage to a company's reputation can largely be avoided through well-implemented, cost-effective practices. To minimize the chances of ESD damage, there are 3 primary areas of focus: personal equipment, working environment, and individual work area. The cost to supply a worker with the proper personal ESD safe equipment can be less than the cost of a single motherboard that has been ruined by an errant ESD event. So it makes good economic sense to be sure each worker is provided with and uses these following few essential tools. First, before entering any ESD safe area, they should put ESD heel straps on each shoe. Once strapped on, the conductive cord should be placed inside the sock so that it makes good contact with the skin. Placing it between the sock and shoe will not provide the necessary grounding, so make sure the cord is in good contact with the skin. As an alternative to the heel straps, ESD-safe shoes can be used. These will have the conductive features needed in an ESD-sensitive area and may also have other industrial features, such as steel toes for use around heavy equipment. A wrist strap should be worn whenever working on electronic products. This strap consists of an elastic band with a contact area, which should be in good contact with the skin. Do not wear it outside any clothing. A coil cord attaches to the wrist strap and then is grounded at the worksite via a clip or banana plug. Finally, an ESD smock should be worn whenever a worker is in an ESD-sensitive workspace. It should be buttoned or snapped closed to be effective. After putting on the heel straps or shoes, the wrist strap and a smock, each person entering an ESD-sensitive area should check their equipment at a test station. If the test fails, the wrist strap or footwear should be checked for damage or improper use and the problem corrected before entering. Normally, both the wrist strap and footwear can be checked at the same test station. Instructions for use should be posted and a log should be kept as each person enters an ESD area. A properly equipped ESD-safe work area will address two key areas: environment and proper grounding. Since dry air contributes to ESD buildup, the work environment should have humidity controls. It is recommended that the humidity level be kept above the industry minimum standard of 21% relative humidity. The flooring system should consist of static dissipative floor tiles installed with a conductive epoxy. They are available in both carpet or vinyl tiles and become one large conductive surface. The entire floor surface is then grounded to the building structure or a grounding terminal. Using the megameter, the floor's conductive property can be measured. By placing the probes according to specifications, a small charge is passed through the floor. The meter can then determine if the floor passes the test. Non-conductive floors will fail the test. Anyone walking across a static dissipating floor should be grounded through properly worn heel straps or ESD shoes. A cart with plastic wheels rolling across the floor can build up a static charge. So any cart used in this area should have conductive wheels and/or a grounding chain. Each ESD-safe workbench should include a bench with a static dissipative work surface or mat and a place to attach a wrist strap. All three items should be connected together and properly grounded. Each individual work area should be kept free of clutter and items which may generate a charge. Questionable items can be checked with a field meter to determine if they pose a threat to ESD-sensitive materials. It is just good practice to remove any items that are not ESD safe. Each bench should have an ESD protective chair. These are made with static dissipative material on the seat cushion and back. the chair is grounded to the floor through wheels that may be made from conductive material or a grounding chain. As a person sits in one of these chairs, they are grounded from their smock, through the chair, and to the floor. Before handling any materials, the wrist strap should be plugged into the grounded receptacle on the workbench. A properly utilized workstation provides multiple paths to ground, affording maximum protection against damage from static charges. Once a worker is properly grounded, they should be able to safely handle and work with ESD-sensitive materials. But since static charges can jump short distances, they should caution others to stay clear of the work area, especially if they are not properly grounded. When finished with any ESD-sensitive item or preparing it for transport, make sure it is properly stored in static shielding containers. The packaging material should fully enclose the item. These preventative measures take little time to implement, do not restrict worker activity, and will quickly pay for themselves through higher yields. Committing to these 5 strategies will ensure the success of an ESD program. Management commitment to provide safe and ESD-friendly facilities and prevention tools. An effective implementation plan that reflects measurable and realistic requirements. Management should consider cost, effectiveness, and social habits. Consistent and frequent communication about the importance of ESD prevention. Regular audits of ESD testing and control processes. And continuous improvement based on business needs and manufacturing capability. If everyone, from assembly worker to management, understands ESD and actively works to prevent it, then your company will be well on its way to reaching its goals as a high-quality manufacturer.